Well, we've now moved to consider permutations and combinations. And a permutation is where we've got objects in a sample space and we're trying to arrange them, but the order is important. And really what we mean by that, if I take one of those objects and place it in this sample space, well, I can't use it again. I got to deal with the remaining objects in the sample space. Now, a combination is one where I got the same thing. In a way that I've got objects in a sample space, but the order is not important. Doesn't matter if it's first, second, or third. They're just going to, I'm picking 3 items to occupy the space, let's say, as an example. But we start here with permutation. So again, permutations where I've got objects in a sample space and the order is important. So for instance, what we have here on the screen, Lloyd and 5 of his friends go to a movie. And how many are going to the movie? There's Lloyd, there's 1, 5 of his friends, that's 6. In how many ways can they sit together in a row of 6 empty seats? Well, the reason why the order is important, let's say that we put Lloyd in the first seat. Well, he occupies that seat, but then I've got 5 friends, 5 additional spaces, but I can't have Lloyd sit in 2 seats. He can't occupy 2 seats at the same time. He's just going to occupy 1 seat. Or say I put Lloyd in the 3rd seat. Well, he's going to be in the 3rd seat. That's it. The friends are going in the first 2 or the last 2. Or last 3. Last 3. And so we have what is called a factorial to determine this. And this builds on the fundamental counting principle. And so then we could initially say that there are 6 factorial ways that we could sit these 6 people in these 6 empty seats. Now, what is 6 factorial? Well, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. In other words, I got 6 people that could occupy, when I start, I got 6 people that could occupy seat 1. But once I seat 1, then I've only got 5 people for seat 2, and so on down the line. Now, in this case, where we got 6 factorial, I could actually probably do that in my head real quick. We're going to move to the calculator, and I'm going to show you how to calculate using factorial. But let's see, 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. Times 1 is 720. But once it gets much higher than 6 factorial, it actually gets pretty hard to do in your head. Now, I could put in there 6 times 5 times 4 times 3 times 2 times 1 in the calculator, and it's going to spit out 720. However, we're going to go to the calculator and look how we can enter factorial into our calculator. All right, we're on the calculator. We're talking about permutations and factorials. And let's say I want to enter 6 factorial into the calculator. Well, I can put in the number 6, and then I go to the math, and I'm going to scroll all the way over here to where it says prob or probability. And right there at number 4, I see the little probability symbol, which looks like an exclamation point. So I'm going to choose option 4. So it is now a 6 factorial, and I'm going to hit enter. And shazam, it's 720. Now, just to prove once we get much higher than 6 factorial, and this gets hard to do in your head. Let's say, for instance, 9 factorial. How about that? I'm going to do 9. Math, probability, option 4, 9 factorial, and there are 362,880 permutations of 9 factorial. Thank God for a calculator. Now, I could put 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 and hit enter. But look how many entries I made versus just 9 factorial. Calculators are our friends.